Hello everybody, welcome to my physics class, Standard 7 Chapter 3, which is about energy. In this chapter, we will discuss about what is energy, different forms of energy, interconversion of energy, law of conservation of energy. So, first we discuss about the definition of energy. Before going to the definition of energy, first of all, we discuss about some common experiences by which we can understand the definition of energy clearly. When you go to play, after playing sometimes some outdoor games like football or cricket, hockey, kabaddi, whatever it is, any kind of outdoor game, you feel tired. While riding bicycle for several hours, you also feel tired. After doing some physical activity for some hours, we feel tired. Why do we feel tired? What makes us feel tired? We feel tired because some part uh, some part of the energy of our body gets exhausted in performing such activities like playing games, riding bicycle, or being involved in any other physical activity. While riding bicycle or playing cricket match, we spend some energy from our body. Our body spend some part of its energy to play the match, to play the cricket match. It means that some of the energy get lost from our body. This is why we feel tired. That makes us feel tired. You know that vehicles need fuel to run. Without fuel, vehicles cannot run. The fuel provides the necessary energy to run the vehicle. Like this, living beings need food to get energy for to perform various activities. Human beings need food to do various activities. Like fuel is required by vehicles, we require food. That food provides us energy, and energy makes us able to do different kind of work. So now let us define energy. So energy is defined as the ability of doing work. Without energy we cannot do our work. So to do work we need energy. As much as we energized, we can perform the work better. Hitting a cricket ball with a bat, riding a bicycle are examples of our body using energy to perform day-to-day activities. As we refill a vehicle with petrol or a source of energy to ensure it can run on the street is an example of energy uses in case of machines. The unit of energy are SI unit of energy is joule and calorie is the CGS unit. You know that 1 joule is the amount of energy applied when a force of 1 Newton displaces a body through a distance of 1 meter. 1 calorie is the amount of heat energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. And remember, 1 calorie is equal to 4.184 joule. Energy is a form of energy. Now we discuss about different forms of energy. Energy exists in various forms. So some of the forms of energy are mechanical energy, heat energy, chemical energy, light energy, muscular energy, nuclear energy, magnetic energy, electrical energy, etc. We will discuss different forms of energy one by one. First of all, we discuss about the mechanical energy. Mechanical energy is the combination of potential energy and kinetic energy. Potential energy is the energy possessed by a body by virtue of its position or configuration. A body, suppose a stone is placed on a ground. The stone is at rest. So due to its rest position, the stone possesses potential energy, which is kept on the top of your building. The stone is kept on the top of your building. The stone possesses potential energy due to its position. The spring, when you stretch a string, the spring also possesses potential energy by virtue of its configuration. Now, kinetic energy. Kinetic energy is the energy possessed by a body due to its motion. The energy possessed by a body due to its motion is known as kinetic energy. The combination of potential energy and kinetic energy is called mechanical energy. Examples of kinetic energy are a running car, a moving stone, a flying bird possess kinetic energy due to their motion. In case of dam, where the water kept stored, the stored water in the dam possesses potential energy, and when the water is allowed to fall, the potential energy gets converted into kinetic energy. The energy of flowing water can run the turbine and generate electricity. Let us understand the concept of mechanical energy with the example of carpenter with iron hammer, a wooden block and a nail. When the carpenter lifts the iron hammer to hit the nail in the wooden block, when the carpenter lifts the iron hammer to a certain height to hit the wooden block, the hammer possesses potential energy, and as much higher it moves as the potential energy of the hammer increases. As it is lifted and reaches a certain height, the potential energy of hammer changes to kinetic energy when the carpenter brings down the hammer to hit the nail. The potential energy and the kinetic energy of the hammer are the two forms of mechanical energy. Chemical energy, the form of energy which is released or becomes available as a result of chemical process, is called chemical energy. The energy stored in fuel, firecrackers, matchsticks, battery are some examples of chemical energy. When wood, petrol or coal is burnt, a lot of heat as well as light energy is produced. We know that both heat and light energy are forms of energy. As earlier we know that energy exists in different forms. So light is a form of energy, heat is a form of energy. When a coal is burnt or petrol is burnt, heat as well as light energy is produced. Now, these energies in petrol or wood, chemical energy is stored. The energy stored in the petrol or wood is in the form of chemical energy. When the wood or petrol is set on fire to burn, it releases heat and light energy. The energy in this case is actually stored in the substance itself as a chemical energy. You will notice that after burning the coal, some ashes left, but this ash does not burn once again. This is because the chemical energy stored in the wood is released when it is burnt, and the ash does not possess any chemical energy, as a result of which it cannot burn. Now, heat energy, the energy obtained from lighted gas, stove, burning coal, wood, or any other fuel is called heat energy. When heat is supplied to a body, its temperature rises and becomes hot. For example, when a utensil is kept on a lighted gas stove, the utensil becomes hot and anything inside the utensil becomes hot. Before we put utensil on the fire, it was cool, but when we keep the utensil on the lighted stove or on the fire, the utensil becomes hot gradually, and if we put anything inside the utensil, suppose we put water inside the utensil, the water also gets heated up. So when the temperature is when heat is supplied to a body, its temperature increases gradually. In thermal power plants, large quantity of water is heated and converted into steam. This steam is then used to rotate the turbine to generate electrical energy. So heat energy has many applications. Some applications of heat energy are cooking food, to generate electricity at thermal power plant. It has a large scale application. Heat energy has a large scale application from cooking food at home to the generation of electricity in thermal power plants. Now, light energy, like heat and other form of energy, light is also a form of energy. This energy can be used to see, this energy can be put to use various useful purposes. Light energy helps us to see the things around us. Light energy is the energy which makes us able to see the beautiful world, without which we are unable to enjoy the beautiness of this world. Plants utilize this energy during the process of photosynthesis. Plants use light energy from the sunlight to prepare its food and store the prepared food in the various parts of the plant. We use sunlight to produce electricity using solar cell. The electricity thus produced can be used to run machines and electric goods. In this picture, it is shown the process of photosynthesis. You know the process of photosynthesis very well. This is a picture of solar panel. That solar panel receives light energy from the sunlight and gets converted it into electrical energy. And this electrical energy helps us to run machines and other electrical appliances. Sound energy, like light. Sound is also a form of energy. Because of the sound energy, that the different sounds are audible to us. When a vibrating object causes surrounding medium to vibrate, sound waves produced. So vibration is the basic cause for the production of sound. So sound waves are produced. We hear sound when these vibrations reaches our ear membrane. When the vibration of the surrounding medium reaches our ear, we hear the sound. The energy that can be obtained from sound is very small, but it is used for various useful purposes, which includes listening. We enjoy the different kinds of beautiful song because of the sound energy. Electrical energy. Electrical energy is the most common and most important form of energy for human being. Electric fans, lights, air conditioner, and all other appliances use electrical energy to do work. Electrical energy is the flow of charges through a conductor. Electrical energy is nothing but the flow of electrons, the flow of charges through a conductor, which is commonly referred to as electricity or electric current. So electric current is defined as the flow of electrons through a conductor. The flow of electrons through a conductor constitute electric current, and that is we call as electricity. And the electricity or from the electric current we get that provides us electrical energy, which helps us to run our different kinds of electrical appliances. Now magnetic energy. Magnetic energy is the energy possessed by a magnet, or the energy possessed by a magnet is called magnetic energy. Magnets attract magnetic materials. The materials which are made up of iron, steel, nickel, and cobalt, and their alloys are called magnetic material, and these magnetic materials get attracted towards the magnet by virtue of magnetic energy. Or magnet attracts magnetic material towards it by virtue of magnetic energy. Magnetic energy, uses of magnetic energy, it is used in crane to lift heavy objects. It is also used in refrigerator to keep the door closed. In this picture, this is the picture of a refrigerator. In refrigerator, magnetic energy is used to keep the door of the refrigerator closed. But in case of lifting of the heavy objects, magnetic energy is used by the cranes to lift the heavy objects to a certain height. Now nuclear energy, you know that atoms, at the center of the atom, a small atoms at the center of the atom, a central mass is present, that is known as nucleus. At the center of the atom, at a very tiny region, almost all the masses of the atoms are concentrated. That central part of the atom is known as nucleus. When the nucleus of an atom splits, means breaks to different fragments, or combines with the nucleus of another atom. When the nucleus of one atom combines with the nucleus of another atom, or when the nucleus of an atom gets splitted into different fragments, huge amount of energy is released. This energy is known as nuclear energy or atomic energy. Nuclear energy or atomic energy is used in large scale nowadays. The energy in the sun is also produced by nuclear reaction. Nuclear energy is used for generating electricity in nuclear power stations. Nuclear energy is also used to diagnose and treat different kind of very dangerous diseases like cancer, heart disease, and abnormalities in the body. Now we discuss about muscular energy. Energy possessed by a body which is obtained from the food. The energy that we get from the food is stored in the form of chemical energy in our muscles. This energy is known as muscular energy, and this energy helps us to perform our day-to-day activities such as running, walking, and is referred to as muscular energy. So let us define muscular energy once again. The energy that we get from the food is stored in the form of chemical energy in our muscles. That energy is known as muscular energy. Interconversion of energy. Energy exists in different forms. As we have discussed earlier, one form of energy gets converted into another form of energy. The change in energy from one form to another form is known as transformation of energy. A bulb consumes electrical energy to produce light. Electrical energy is used by music system to produce sound, and electrical energy is used in heater to produce heat. So we see that electrical energy can be converted into various types of energy, such as light energy, sound energy, heat energy, etc., etc. In torch, chemical energy stored in the battery is converted into light energy, and in firecracker, chemical energy is converted into light energy and heat energy and sound energy. When a firecracker is burnt, it releases light energy, heat energy, and sound energy. In a Bunsen burner, chemical energy stored in the gas is converted into heat and light energy. In a car, the chemical energy of the petrol or diesel is converted into kinetic energy of the car. That fuel helps the car to run. It means that the chemical energy of the petrol gets converted into kinetic energy or the mechanical energy. When we rub our hands to generate warmth, muscular energy gets converted into heat energy. When you shoot an arrow from a bow, the arrow moves towards the target. In this case, the energy stored in the bow, that is potential energy, gets converted into kinetic energy. In the string of the arrow, potential energy is stored. When the in the string of the bow, potential energy gets stored when the arrow is shot to hit its target. The potential energy of the string of the bow gets converted into kinetic energy. In the electrical appliances such as fan, mixer, grinder, and washing machine, electrical energy changes to mechanical energy. Now we discuss about laws of conservation of energy. The law of conservation of energy states that energy can neither be created nor be destroyed, but it can be converted from one form of energy to another form of energy. The total energy of the universe remains the same. The total energy of an isolated system remains the same. On Diwali, you have that experience. On Diwali, many people burn firecrackers, which is made of chemical substances. These chemicals have chemical energy stored in them. When the firecrackers are burnt, you see light energy, you hear sound energy, and you may feel the heat from the burning firecrackers. It means that the chemical energy of the firecracker gets transformed into three other various forms, such as light energy in the form of light energy, sound energy, and heat energy. But the total energy of the fire of the system remains the same. We can say that chemical energy stored in the firecrackers is not destroyed. The chemical energy stored in the firecrackers before it is burnt is equal to the sum of the sound energy, light energy, and heat energy when it is set into fire. It means that the chemical energy present in the firecrackers does not destroy, but it gets converted into other forms of energy such as heat energy, light energy, and sound energy. So you can say that total amount of energy remains conserved. This is all about the chapter energy. Thank you very much.